This is Maths Chapter 5 Sets. So, there are many new concepts to be introduced in this chapter. Please pay attention and wherever necessary, please take notes. Okay, let's begin. So, what is an object? In mathematical language, see, in physics, object is something which has mass and which occupies space, just like matter. But in mathematical language, everything in this universe, whether living or non living, is called an object. Well defined collection of objects. A collection of objects is said to be well defined if it is possible to tell beyond doubt about each object of the universe, whether it is there in our collection or not. So, we have to make a well defined collection of objects in the chapter sets. Set is a well defined collection of distinct objects. Distinct. What do you mean by distinct? Distinct means different from each other. That means a set is such a group of objects in which no two objects are same. Every object is different from each other. So that's a set. Elements of a set. The objects in a set, the objects in a set are called its members or elements. The objects in a set are called its members or elements. We usually denote sets by capital letters such as A, B, C, etc. and their elements by small letters such as small a, small b, small c, small x, small y, small z, etc. If X is an element of set A, we say that X belongs to set A and we write it as X belongs to A, where this is a special symbol. X belongs to set A. This is the symbol which is known as epsilon. It's a Greek letter, epsilon, which means here in mathematical language it means belongs to. Okay, in set language it means belongs to. So X belongs to A. So what do you mean by that? X is a member of set A. X is an element of set A. If X is not an element of set A, we say that X does not belong to set A and we write X does not belong to A. Examples of sets and its members. Let us consider the collection A of first 5 prime numbers. So, the set A can be written as A is equal to curly bracket 2, 3, 5, 7, 11. As you can see here, each element or each member of set A is written besides another separated by a comma, and all these numbers are enclosed within curly brackets. All these numbers are enclosed within curly brackets. Okay, so the collection A is equal to 2, 3, 5, 7, 11 is a set. Clearly, we can say that 2 belongs to set A, 3 belongs to set A, 5 belongs to set A, 7 belongs to set A, and 11 also belongs to set A. But 1 does not belong to set A. 4 does not belong to set A. Small a is not part of set A, does not belong to set A. Half also does not belong to set A. Right? So, in this set, is any number repeating? No, all of the numbers are distinct, different from each other. So this is a set of first 5 prime numbers. Do you know what is a prime number? This is not part of your set theory, but you should know what is a prime number. Prime number is certain number which has only two factors, 1 and the number itself. So smallest prime number is 2. After that, the next prime number is 3. So 2 and 3 are the only prime numbers which are consecutive. Consecutive means which occur one after another. Okay. So this is basically the set of all prime numbers. Consider the collection of all interesting books in a library. Here, the term interesting is vague. Vague means it is not exact. What do you call an interesting book? I don't think it is interesting. What I call an interesting book, you might not think that it's interesting. So the concept of interesting books differs from you and me, differs from for you and me, differs from person to person. Every person thinks a certain book or a certain topic or a certain subject on which the book is written is interesting or not interesting, and that choice depends on individual thinking. So that is not well defined. Interesting book is such a category of objects which is not well defined. Okay, so here we cannot make a set out of all the interesting books in a library, because it is simply not well defined, and because it is not well defined, it cannot be considered as a set. Let us consider the collection of all tall boys in class. Now, what do you mean by tall boys? In a class where the height of all the boys are average, in that category, the definition of tall boy does not fit well, because tall, who is considered to be tall? How tall a person should be for him to be called tall also applies to a certain age group. In the age group 13-14 years, certain students are very tall, certain students are not very tall. But then what is tall? Group of tall students. That is not well defined. That is just a vague term. Okay. So collection of tall boys in a class is not a set. Yeah, but if they say that collection of all boys in a class with height more than 150 centimeter, now they are defining it properly. So this can be called as a set. Collection of all boys in a class with height more than 150 centimeter is a set. Similarly, collection of handsome boys, famous poets, healthy children, good players, rich persons, dishonest men, fat people, beautiful painting are not sets, because these are all vague definitions. These are not well defined definition, right? Okay. How to describe a set? See, there are two methods for describing a set. Number one, roster method. Number two, tabular method. I'm sorry. Number one, roster method or tabular method. Number two, set builder form or rule method or description method. I'm going to teach you both the techniques. So we are generally going to name them, or you can say we are generally going to identify them by the name of roster method and set builder method. Okay. Roster method or tabular form. Under this method, we just make a list of the elements of the set and put it within curly brackets. That is, for example, set of all prime numbers between 30 and 50. Curly bracket डाल दिए और curly bracket के अंदर 31, 37, 41, 43, 47. So list of all set of all prime numbers between 30 and 50 ready हो गया. B, be the set of all even numbers less than 1000. 2, 4, 6, 8, up to 1000. Even numbers less than 1000. Let C be the set of all odd numbers greater than 100. 101, 103, 105, 107, and dot 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 dot. That means this is an infinite set. I'm going to talk about infinite sets further also, but this is known as infinite sets. Just a moment. Okay, so are you getting the idea about what I'm talking about? The method with which I'm expressing a set, in which inside curly brackets all the elements or all the objects of the set are listed, just separated by a comma. Okay, so this simple method of listing the elements of a set is known as roster method or tabular form. Okay, One more example, D, the set of all integers less than 2. So you put dot dot dot, that means there are infinite integers less than 2, then -3, -2, -1, 0 and 1. So this is also an infinite set. Okay. There are few things to note about roster method or tabular form. Number one, every repeated element is taken only once in a set. So suppose we have a set of 1, 2, 1, comma 2, comma 3 and 1. Now 1 is repeated, 1 is written twice. We do not write it twice, we just write it once. The order in which the elements of a set are listed is immaterial. Immaterial means does not matter, right? A, B, C, E, M. A, comma B, comma C, comma E, comma M is equal to A, comma M, comma C, comma B, comma E. So the order in which the elements of a set are listed is immaterial. Second is set builder form or rule method or description method. Now that you have understood what is roster method, you can easily understand what is set builder form. Under this method, we list the properties satisfied by all the elements of a set. That is, we just give a description of the elements of the set and put it within the braces. So we write inside curly bracket x such that x has all the properties of P, all the properties P. It means the set of all those x elements. X elements means all the elements which are part of this set, such that each element x satisfy the properties P. We use the symbol vertical line or two dots for such that. That means, please remember, vertical line or double dot, two dots means such that. Let's look at some example of set builder form. So in roster form, if you have in curly brackets 1, comma 2, comma 3, comma 4, comma 5, comma 6, we can write that in set builder form as x such that x belongs to n, x such that set A is a set of all the elements x such that x belongs to n, that is uh, x is a natural number, x belongs to natural number, and x is smaller than 7, x is smaller than 7. Now in the place of x is smaller than 7, if somebody had written x is smaller than equal to 6, then also it is correct. A natural number smaller than 7 is 1, 2, 3, 4, 5, 6. A natural number smaller than equal to 6 is also 1, 2, 3, 4, 5, 6. Then -2 to 3. Now here it is not natural number, it is z. Z means integer. Z is the symbol of integers. X such that x belongs to z, set of integers, and x is greater than equal to -2 and smaller than equal to 3. Right? X is all such, x is a set, this is a set of all integers such that um, x is greater than equal to -2 and smaller than equal to 3. Okay. After this, we have 1, 2, 3, 4, 6, 8, 12, 24. Now, if you think closely, these are all the factors of 24, including 1 and 24. All are the factors of 24. So, x such that x is a factor of 24 is a set builder form of this set. 8, 10, 12, 14, 16, 18. So these are all even numbers between 8 and 18. So x such that x is equal to 2n, where n belongs to natural number. Why 2n? Because 2 multiplied by any number is a even number, right? Where n is smaller than equal to, sorry, greater than equal to 4 and smaller than equal to 9. 16, 25, 36, 49, 64, 81, 100. All are perfect squares from 4 up to 10. So x, this set is of all x such that x is equal to n square, n belongs to natural number where n is greater than equal to 4 and smaller than equal to 10. X is equal to 2n minus 1 when n belongs to where n belongs to natural numbers, set of natural numbers. Okay, so 2n minus 1, what is 2n minus 1? 2n minus 1 is a odd number. Why they haven't written 2n plus 1? I'll tell you why. See, uh, natural numbers, they begin from 1. Okay, here they have also said that n belongs to n is greater than equal to 1 and smaller than 8. Okay, so our first number is 1. Our first number is 1. Now if we want the first number, the first odd number over here as 1, we cannot take 2n plus 1. Then n will be 0. N has to be taken as 0 and n will not belong to natural number in that case. That's why they have taken 2n minus 1. So whenever you see 2n minus 1, understand that it is a odd number. Whenever you see 2n, understand that it is a even number. Okay, so 2n minus 1, it's a odd number. After that we have 1 by 2, 2 by 3, 3 by 4, 4 by 5 and so on. So this is the format of n by n plus 1. This is the format of n by n plus 1. Okay, where small n belongs to natural number, n by n plus 1. N is 1, the denominator is 1 plus 1. N is 2, the denominator is 2 plus 1. N is 3, the denominator is 3 plus 1. So denominator is always 1 more than the numerator, right? Next is 3 comma minus 4. Now this is very unique. This is the solution of this quadratic equation. I'm sure you don't have much idea regarding quadratic equations right now, so we are not worried about the 8th example. Let's look at the next example, 5, 10, 15, 20, 25. Now these are all multiples of 5. So x is equal to 5n, where n belongs to whole numbers, n is greater than equal to 0 and smaller than equal to 6. Okay, so this is direct comparison between roster form and set builder form. Okay, the next thing you should know is the standard sets. Standard set are the set of natural numbers, set of whole numbers, set of integers and set of rational numbers. Out of which set of rational number is unique because we have studied rational numbers. Rational numbers are always in the form of p by q, where p and q both belong to integers and q is not equal to 0. P and q both belongs to integers and q is not equal to 0. That is the set of natural numbers. Then I told you about finite and infinite sets also. A set in which the process of counting of elements surely comes to an end is called finite set. That means finite set has countable number of elements. For example, set of all prime numbers less than 10, less than 100, finite set. These all are examples of finite set, but this is written in set builder form. X such that x belongs to natural number and x is smaller than 50 lakh. Of course, it's a finite set. Sometimes we cannot count the objects of finite set, but we know that the counting process surely comes to an end. For example, set of all persons on the earth. We cannot count physically, but we know that there are only finite people on the earth. Set of all the trains in the world. Set of all the trees on the earth. All finite sets. Infinite set. A set which consists of an uncountable number of distinct elements is called an infinite set. Thus, if we go on counting the elements of an infinite set, then the counting process never comes to an end. For example, set of all natural numbers, set of all integers which are smaller than 10, set of all rational numbers between 0 and 1. Of course, they are infinite. There are infinite rational numbers between two natural numbers. Set of all concentric circles with a given center. the set of all points on an arc of a circle. These are all infinite sets. Cardinal number of a finite set. Suppose there is a set 2, 3, 5, 7, 11, 13, 17. How many elements are there? 7 elements. So cardinal number of set A is 7. So number of distinct elements contained in a finite set is called the cardinal number of the set. Okay. For example, if we get let's say set builder form of set B such that set B of all the elements x such that x is a letter of the word mathematics. Now if you write the letters of the word mathematics in roster form, you will understand that there are many letters which are repeating themselves, and you are not allowed to repeat any object, any element, any letter in the set. So you will write M once, A once, T once, H once, E, I, C and S. Only 8 letters are distinct. That means the cardinal number of set B is 8. Empty set. A set consisting of no element at all is called an empty set or null set or void set. It is denoted by phi. Actually, the spelling given over here is wrong. The actual spelling is phi, sometimes also known as phi. Okay, so this is a Greek letter which denotes an empty set. In roster form, we write phi as empty curly brackets. The number of elements in an empty set is always 0. Remember that. For example, all the elements of a set X such that X belongs to real number, comma X not equal to X. X not equal to X. Okay, so this is little tricky. This is little tricky because I do not know what do they mean by X not equal to X. Anyways, let's check another set of all elements X such that X belongs to natural number and X is between 1 and 2. Between 1 and 2 there exist no natural numbers because 1 and 2 themselves are consecutive natural numbers. Between two consecutive natural numbers there cannot exist any other natural number, so it's an empty set. Next, X such that X is an even prime number and X is greater than 5. Even prime number. There is only one even prime number which is 2. There is no other even prime number. Greater than 5, there is no other prime number, even prime number. All the prime numbers greater than 5 are odd, and that's why this is a null set. X such that X belongs to real numbers and X square is equal to -1. No number's square can be negative. So X square is equal to minus 1 is a null set. Non-empty set. A set which has at least one element is called a non-empty set. Singleton set. A set containing exactly one element is called a singleton set. So if you want, you can take notes of these things as I speak. Okay, that will be beneficial to you. Examples. This is a singleton set because it contains only one element, 2. X such that X is an even prime number, singleton set. X such that X is a month having less than 30 days, singleton set, February only. Okay. First example, the most interesting in the example is the first example. Show that phi, 0 inside set and 0 are all different. What is phi? Phi is a set containing no elements at all. What is 0? 0 is a set containing one element, namely 0. And 0 is a number, it's not a set. So all are different. First two are sets, third one is a number. First is an empty set, second one is not an empty set, and third one is not a set at all. It is just a number. Equal sets. Two sets A and B are said to be equal, written as A is equal to B if every element of A is in B and every element of B is in A. If two sets are not equal, we write A is not equal to B. For example, X such that X, let A be the set of all elements X such that X belongs to whole number and X does not belong to natural number. And B is a set of all elements X such that X belongs to integers and X is neither positive nor negative. Okay, so that means we have to find a whole number which is not natural. There are many whole number, sorry, there is only one whole number which is not natural, which is 0. And we have to find an integer which is neither negative nor positive. There is only one integer which is neither negative nor positive, that is 0. So A and B both are set of 0, that is A is equal to B. X such that P is a set of all the elements X such that X is a letter in the word follow. What will its roster form have? F, O, W, L and W. And Q is equal to X such that X is a letter of the word wolf, such that Q is equal to W, O, L, F. Clearly P is equal to Q. Here, note that the order in which the elements of a set are listed is immaterial. The repetition of the elements in a set is meaningless. Okay, so we do not repeat the elements of the set, neither we take care of the order. Does not matter in which the elements are listed, their order does not matter. The set n of all natural numbers and the set w of all whole numbers are not equal because set w has one element extra, which is 0. So n is not equal to w. So that's about equality of set. One more thing, equivalent sets. Two finite sets A and B are said to be equivalent and written as A is equivalent to B if they both have same cardinal numbers, same number of elements. For example, A, comma, E, comma, I, comma, O, comma, U and B 1, comma, 2, comma, 3, comma, 4, comma, 5 both have same cardinal numbers 5 and there is that therefore we can say that A is equivalent to B. Two equal sets are always equivalent, but two equivalent sets need not be equal. All right. Okay, great. So we have studied a lot of things in the first part of the chapter. And then there is this exercise 5A, which has all the questions based on the topics which we have just saw. Okay, so I'm going to stop this video and I'm going to suggest you to complete this exercise 5A after watching this video. That will clear all your concepts and that will also help you remember all the concepts which you studied today. Okay, so I'll see you in the next video. Please do the exercise 5A yourself. Bye bye.